Hey everyone, welcome back. And in this clip, we would like to explore the different possibilities of creating a fluid emitter, with each one having its own benefit. So before I start creating the fluid emitters, it's required to create the fluid containers and also to understand the fluid shape nodes. So for that, we need to go inside the FX menu. We have a dedicated fluid menu over here, and we could go inside the create and can go for the 3D containers. Okay. And before I just click the apply and close button, I would also like to go for the reset setting. So if in case anyone would have used this machine or have got to change the attribute of this 3D container, we could just simply reset them. All right. So here it is showing that add emitter and the type is set to be the Omni. Okay, so in this case I would like to say do not add it, and let's say we would like to create apply and close. We first would like to visualize the fluid container, which is the heart of the fluid. And as you know that we have understood from the module 1 that all the fluids has to be contained inside the local and the limited domain of this fluid container. The fluids can never exist outside the fluid containers. All right, that is very important. So once you create the fluid container, you can see that this is made up of the voxels. But where is the voxels, or where are the voxels? Well, the thing is that if you could just take a look at the bottom side, let me just gonna hide the grid for a moment. And this grid is something showing me pretty interesting things. This is the representation of the voxels. Okay, this particular square is representing a voxels, but we were told once that voxel is a tiny cube, because as far as the voxels are concerned, it simply says that each individual unit of this XY grid is called as a voxel. So that means voxel has to be a cube, it has to be a 3D, it cannot be a 2D. So to visualize that, we can go inside the fluid shape and can, under the display, we could take a look at the boundary draw, and instead of the bottom we could click to the full. So the moment we click the full, now you can see that something 3D has started happening. So all this small square boxes, or you can say not the square boxes but the small cubes, they are the representations of the voxels. All right, so right now I have the base 10 resolutions, and the size of the fluid container is also 10. So that means 1 voxels per single unit. And what's the basic unit? That's a centimeter. So if you're going to use little maths, it simply means that for 1 centimeter we have 1 voxels, which is fairly a very less thing. All right, and this is absolutely going to be very less. This is the least of the least resolutions I could ever say. So in order to increase that, in order to let's say we want visually rich image or visually rich effects, we need to upres, or we need to increase the base resolutions. So instead of the 10, let's say I'd like to begin with 100. So that means it has added a lot of resolutions inside the each unit of the voxel grid. All right, now we do have a lot of voxels density inside the fluid containers. All right, but it also giving me a lot of problem in visualizing things, because with this kind of look and feel, it's almost next to impossible to visualize what exactly is existing inside the fluid container. So what do I need to do in that case? The simple thing is that I can revisit the boundary draw. Instead of the full, or instead of the bounding box, or let's say instead of the bottom and the full, I would like to click to the bounding box. So it simply means that it will going to retain all the necessary informations of the voxels, but visually it's pretty much clear. And I tell you, how do we going to count the voxels? We need to multiply this 100 over 3 times. So the result will go somewhere around a million, I should say. I think so. Let's take the help of a simple calculator, and let's say 100 multiplied by the 100 multiply by the 100, and it is giving you somewhere around 1 million. So that means your fluid container is now having 1 million voxels, all right, which isn't a very big thing because now these days we could take this figure from 100 to 300, maybe to the 500 also, all right. So now the things have been really upgraded, so don't worry about that, we're gonna come on that a little later. So now we would like to focus upon the visualization of the fluids. So that could be possible only if we insert the emitter inside the fluids. And remember that the emitters are not adding the voxel inside the grids. The voxels are already there. The emitter will just only going to modify the properties of the voxels with respect to the density, because that's the only look and feel property we could able to visualize. All right. So I need to go inside the fluid again, and let's say add edit contents. I would like to initiate an emitter. Okay, so we need to go over here, and what type of emitter you're looking forward for. Let's say we begin with the default with the first only. That means the Omni, or you may also could call it as a point emitters. Apply and close. So you can notice that the moment you apply and close, and you also like to go inside the outliner where you're going to see two things. One is the fluid, which is the shape node of the fluids. I mean, this is the basic node of the fluid. Here inside this we can see this is the shape node, which is the heart of the fluid. It's been attached with the in the attribute editor with the transform node, which helps to move and rotate and resize this fluid containers. The time node that we're going to take down the information from the time frame over here, and the fluid emitter which we just added, that would going to modify the property of the voxels. So if we're going to click this, and we need to put it at the bottom, so make sure that it shouldn't cross the region of the 3D fluid containers, and without any change inside the properties of the fluid container, I would simply like to play. But before I play, I would also like to confirm my resolution, which is quite high, so I would like to dip it down to the 75. And another thing that I would like to draw your attention towards, the important parameters of the container properties. We do have something called as a keep voxels square, that we understood from the first module, that all the voxels, they are required to be a perfect cube. We cannot just stretch this emitter something like in this way. If we are doing this, we are killing our fluids. It's similar like that. You just had a snap, you just give a click, take that info or take that pic or image inside the Photoshop or any of your editing package. You press the Ctrl T, the transformation tool, and try stretching it out to the horizontal directions. What will going to happen? The image will going to lose its aspect ratio. That means the pixel aspect ratio, which is always a square, it will going to be get destroyed, and what will happen? Your pixels will be stretched, and you're going to destroy the essence of your click. So in a similar way, we are also destroying the overall, you may could say, the look and feel of the fluids by stretching it down. So the one important thing is that you will never ever going to scale the fluid non-proportionally. All right, if it is required, you may could scale it, it's not a problem, but this is the uniform scale. That means you are scaling the fluid from all the three XYZ axes. That's not a problem, but uniform scale is the only solution. Non-uniformly, you can never ever scale the fluids. All right, but what if in case I need some small kind of a container? So right now we have a cube. What if we want a cuboid? That's simple, we don't need to worry about that. We need to visit the size over here, and remember that this particular option is already checked on, which means keep voxel square. So if I do have changes in the sizes, then still the allocations of the pixels will going to be maintained in a square way. Okay, so let's say we have 6:6. So now you can see that from the cube it has been converted into a cuboid or a rectangular box. Okay, so now if I would like to play the timeline, you can see that the fluid has just started, appearing inside the fluid container, and the anticipation is because of the fluid emitter. So I don't want to do anything else inside the fluid shape node. Let's keep them closed for now. Let's go inside the fluid emitters. All right. So here is the most important thing that will going to take place. So the first thing is that we have the fluid attributes. Okay. We have the density method, we have the heat method, and we have the fuel method. But in this case, I would be considering only the density method. I don't need to have the heat, I don't need to have the fuel. Okay, so put them to off and put them to off. So that would be easier for us to visualize things. All right. So we have the density method set to the add. There are two methods, add and replace. Both they have got their own meanings as the name suggests. Add means it will simply going to add the properties of the voxels inside to the empty voxels. And replace means that they will going to replace the entire properties of the voxels inside the fluid containers. Alright. So replace are good if in case you're trying to do some liquid sims inside the fluid containers, although it's never recommended because after the launch of the Bifrost we never ever going to do any liquid simulation inside the fluids. However, you may could do, but the solvers are not like that much sophisticated or actually made to handle the liquid stuff. The solver inside the Maya, which is a Navier-Stokes equations based solver, is capable enough of handling the fluid that is related to the gas, or you could say air stuff. Alright, now moving ahead, we have something called over here is the density voxels per seconds, or density per voxels per second. So that means we are adding the value, the magnitude 1 to that. So obviously we could increase that. What if I would like to have it 10? So you're going to notice that the density will going to get increased. Now you can simply visualize that the fluids have started getting accumulated inside the fluid containers, and notice that how realistically the fluids are also acting to the boundaries of the fluids. Okay, we don't need to worry about that. We could simply make this adjustment that we could make this fluids boundless. That means the fluid will going to stay inside the boundary of this container, but this boundary will not be only limited to this particular size, but that kind of thing will be going to visualize a little later. So as if for now you have learned the process of adding an emitter inside the fluid, and I can also transform that. It's not a problem. Alright, and that's pretty much good. So this is all for this clip. In the next clip we would like to move to another emitter, that is the volume emitters. Alright, so let's get started with that.